In this video, we're going to go through polynomial long division. So we're just going to do a quick warm-up to review how long division for numbers works. And you're going to see that polynomial long division works almost exactly the same way. So if we had to divide 31 into 546, you would first ask yourself how many times 31 goes into 54. So in other words, what number do you have to multiply 31 by to go into 54? Well, I would work with 54 and not 546 because this is 2 digits and that's 2 digits. We're going to see that connection with polynomial long division. So 31 goes into 54 once. Then we multiply the 1 with the 31. We get 31. And then we subtract this and we get 23. So again, after we say what that number is up top, we multiply, write that below, subtract. Next, we bring down the 6. Now we have to see what we need to multiply 31 by to go into 236. That gives us 7. And then we do 7 times 31, and we get 217. Then we subtract. We get 19 as our remainder. If we think about how the 31, 17, remainder of 19 are all connected, what this is saying is 17 times 31 plus 19 gives us 546. If you look at our original problem, it was 546 divided by 31. If I want to see how to write that at the end, I want to divide 546 by 31. If I do that on the left side of the equation, I have to do it on the right side of the equation to both terms. So if I divide everything by 31, the 31s will cancel out here, and I'll have that 546 over 31 is 17 plus 19 over 31. Why I've done this is to remind ourselves that when we write our quotient and our remainder, what we do is we write our quotient and then we add the remainder over the divisor. And we're going to use this form to write our final answer with polynomial long division. Okay, so try to review these steps if you need to one more time, and now we're going to look at polynomial long division. Alright, this is a quick review. This is basically just connecting a few things that are all the same. Okay, so if you were to factor a polynomial, if x minus a is one of the factors, that means that a would be a 0. Or a would be an answer to solve the equation where y is 0. So in other words, a is a 0 of the graph, also called root of the graph, also called the x-intercept, because this is where y crosses the x-axis, because y is 0 when we're finding the zeros. So if we're asked to find the zeros of this equation, we would replace y with a 0 and figure out what x is. If we graphed this, so if I graph the right-hand side right here, if I graph that cubic polynomial, I'm looking for where y is 0. So y is 0 along the x-axis at these 3 points. If you look at your graph, this point is clearly a 0 of x equals 2. The other zeros are not as clear, and we're going to try figuring that out algebraically. You could also determine this on your graphing calculator, which we'll learn about next class. But if you saw that x equals 2 as a 0, that would mean that x minus 2 would have been the factor it comes from if you factored this out. So in other words, if you rewrote this as x minus 2 times some other sets of parentheses. And that's what I have right here. So f of x is x minus 2 times something else. We have to figure out those factors. If we want to determine what these are, we could divide both sides of this equation by x minus 2. Because that would cancel out this, and then we'd be left with those other factors. So that's what we're going to do. We're going to try dividing f of x by x minus 2 to see what those other factors are. So we would know how to factor our entire polynomial and find these other 2 zeros that we can't figure out from the graph. So here's the setup. I've taken f of x, and I'm dividing by x minus 2. Now, just like long division with numbers, you would count off how many digits you have here and try to put it into that number of digits in the beginning of the number. With a polynomial, what you do is you say, okay, my divisor is 2 terms, So I'm going to try to figure out how many times it goes into the first two terms. To figure that out, you only focus on the first term in that. So what I'm going to do is I'm going to ask myself, what do I have to multiply x by to get x cubed? And the answer is you'd have to multiply by x squared. You need 2 more x's. When I write that up top, please line it up over the x squared term. That will help the whole division work out nicely if you keep it lined up. Okay, so I know this goes in x squared number of times with some remainder. Next, what we do is we then multiply the x squared with x minus 2. This parallels the idea of multiplying your number up top with the number you're dividing by and then writing it below. So we're going to do that. X squared times x is x cubed. X squared times negative 2 is negative 2x squared. And again, like numbers, you now subtract this to see what you're left with, and then you bring the next part down. When I subtract it, the x cubes cancel. 4 minus negative 2x squared is 6x squared. And then you bring the negative 5x down. I highly recommend that you write the negative out front with a set of parentheses, and then you can think about distributing the sign. Don't try to distribute the sign right away, or you might make some mistakes. If you can do that, fine, but it's a lot of mental math to do all at once. So after I brought that down, I repeat this process. So now I compare the first terms in each, and I ask myself, what do I have to multiply x by to get 6x squared? I need to multiply by another x, and I need to multiply by 6. So we're going to write 6x up top, and now I go ahead and I multiply 6x with the whole divisor, x minus 2, and when I do that, I'm going to get 6x squared minus 12x. And now again, write the negative out front, put in your parentheses, now you're ready to subtract. So the 6x squareds cancel. Negative 5x minus negative 12x becomes negative 5x plus 12x, so I get 7x. And now I can bring down the negative 14. Now we do this process one more time. So we ask ourselves, what do I have to multiply x by to get 7x? The answer is 7. So put a plus 7 up front. Now multiply the 7 with the entire thing, x minus 2, and you'll get 7x minus 14. And now I'm ready to subtract that, and I get 0. Okay, this is good that I got 0, because again, I'm trying to factor this original polynomial. I already know that x minus 2 is a factor. So when I divide this by x minus 2, I shouldn't have a remainder if I can fully factor this polynomial after I divide it by x minus 2. So what we're saying is this equals x minus 2 times that quotient left over at the end. To finish factoring, you would then have to factor this quadratic. So what we're trying to do is look for factors of 7 that add up to 6. The problem is there actually aren't any factors. 7 only factors is 7 and 1, but because 7 is positive, it's either 2 positive factors or 2 negative factors. So you can do positive 7 and positive 1, but that adds up to 8, not 6. Or you can do negative 1 and negative 7, but that adds up to negative 8. So you can't factor it. So you have to use the quadratic formula to try to determine the other 2 roots. So our quadratic formula, again, is negative b plus or minus the square root of b squared minus 4ac all over 2a. If you do not have this formula memorized, please take the time to memorize it. You will need to know that for your test coming up. The a, b, and c go in order. So a is your coefficient on x squared, b is your coefficient on x, c is the constant at the end. So plug in everything. Negative b plus or minus the square root of b squared minus 4 times a, which is 1. I could have written 4 times 1, and then times c, which is 7. I just didn't write the 1, but include it if that helps you. And then I put this over 2 times a, so 2 times 1. Simplify what's under the square root first, so 36 minus 28 is 8. Now simplify what the square root of 8 is. not a perfect square, but it does have a perfect square factor. Since this is 4 times 2, I want to take the 4 out from the square root, and when I do that, I actually take the square root. So I bring a 2 out front. Now at the end, negative 6 and 2 root 2 are both divisible by 2, so I can cancel out a 2 with the numerator. And you end up with negative 3 plus or minus root 2. So that is what the other 2 zeros on your graph were, which again, you obviously wouldn't know if you just tried to guess. It's hard to guess a radical root. So to be exact, we had to use this process. An important thing to note is when you're doing polynomial long division, you have to account for missing terms. So if you look here, I have an x to the 4th, an x cubed term, and then an x term. So I'm missing an x squared term. And in here, I'm missing an x term. So when I set up the long division, I have to write plus 0x squared, because I was missing that here. When I divide by this, I have to write plus 0x. This is really important so everything lines up correctly. Otherwise, it's going to be very confusing to do your long division. Take a minute and try this on your own. So go ahead and pause the video. And when you're done, you can come back and I'll show you the answer. So this is all the work for the long division. I'll quickly summarize it. Now, I don't like that this was written over here. I would have written the x squared over here. So hopefully you had x squared minus 2x plus 3. Some people do write it this way, but again, line up all your x squared terms. So shift this the quotient answer over. But anyhow, the process again is you start by saying, what do I have to multiply x squared by to get x to the 4th? You need to multiply by an x squared. So then you multiply x squared by all 3 of these, and you get x to the 4th plus 0x cubed minus 3x squared. Now throw the negative out front in the parentheses. You're going to subtract everything. These cancel out. Negative 2 minus 0 is still negative 2x cubed. 0 minus negative 3 becomes positive 3x squared. Then you bring down the 8x. And now we do the process again. X squared times what gives us negative 2x cubed. You have to multiply by a negative 2 and an x. When you do that, you get negative 2x cubed. Multiply 0 by negative 2x, and you get 0x squared. And lastly, you multiply the negative 2 by negative 3, and we get positive 6x. Now you can subtract that answer. These cancel out, as they should. 3 minus nothing is still 3. 8 minus 6 is 2x. Now I'll bring down the negative 14. Again, look at the very first terms in each. X squared times what is 3x squared? The answer is 3. And now you multiply 3 by the whole divisor. 3 times x squared is 3x squared. 3 times 0x is 0x. 3 times negative 3 is negative 9. Throw in the negative, throw in the parentheses, now subtract everything. These cancel. 2 minus nothing is 2. Negative 14 minus negative 9 is negative 14 plus 9. We get negative 5. So that's our remainder at the end. To write our final answer, what we do is we write our quotient. So write the quotient right here. And then you add your remainder over your divisor, which was x squared minus 3. You don't need to include 0x in your final answer. If you did, I wouldn't take off, but you don't need to do that.